Hey folks, welcome to another episode of Frank's Hot Takes. I know it's been a while, but today I want to talk about something that is a little bit different from the usual type of content. I want to talk about why performance matters for a vector database. And I think I've sort of seen some other hot takes out there where people talk about, hey, all that matters is developer experience, or all that matters is cramming a lot of text-related search functionalities into my vector database. And I want to talk about based on a lot of real-world use cases, a lot of real-world applications that we've seen from our customers on top of Zillow's cloud, why that's simply not true. The first one that I want to talk about is agents, automated agents, or things like customer service representatives, customer service bots. Now, if you think about this type of application, what you are doing is every time an end user, a customer interacts with your bot, with this bot, not only are they potentially uploading many forms of data, things like images, text, audio snippets, but on top of that, you need a vector database to be able to retrieve the most relevant information from all of this as well. The first application that I want to talk about is agents. It's things like customer service representatives, automated bots like that. Now, for this type of application, we've actually seen many different types of these applications on Zillow's cloud already. What you can think about is there are so many different workloads that you have to support when it comes to a vector database. It's not just about querying. It's not just about inserting your documents into a vector database and pulling the most relevant ones. As your customer is talking to your bot, you need to think about things like, hey, I need to index images or audio snippets or other text or descriptions that my customer uploads. And as my bot is conversing with them, I need to be able to pull the most relevant ones, either from history or from my existing knowledge base of, let's say, products or other content that I have internally in my database. And what becomes important there is not just read speed. It's not just, hey, can I handle read workloads? I also need to be able to handle high insertion rates. I also need to be able to handle a lot of filtered searches. And if you talk about, even a very, very simple bot, that ends up being, if you scale very, very quickly as the number of messages goes up, and you need a vector database to be able to handle all of that. And that really our today's announcement of Cardinal, where we actually have our own proprietary search index, that ties in very, very well with that, right? That's why you need a really, really performant system, a really, really performant vector database for you to be able to do all those different types of workloads. And the second application that I want to talk about, and we've seen this, it's a bit of a throwback as well, I would say, is recommender systems. And it doesn't matter what I'm trying to recommend. It could be user-generated content, it could be products, or it could be any type of data that I have internally. It could even be personalized search. But I want really, really low latency. I want to be able to search through my database very, very quickly and get all these results back to the user, because that's what really makes a good user experience at the end of the day. Oftentimes, I want latencies within 10 milliseconds as well. And if you do vector search, for folks who are really familiar with vectors and proximity neighbor search, that is actually pretty difficult to achieve once we start getting to 10, 100 million, or even billion scale. But Zillow's cloud, and again, with our Cardinal search engine, with a lot of the things that we've released today, it is fully capable of doing that type of query workload. It's really fully capable of doing low latency queries simply because we have put a lot of effort and a lot of energy towards that. At the end of the day, that's why a lot of our customers decided to choose Zillow's rather than some other vector database. And one last thing that I want to leave everybody off with, not really related to performance, but as we go further, you're going to see a lot more different sort of query patterns, or what I like to call workloads on Zillow's cloud and potentially other vector databases as well. I'll give you an example. Fraud detection, molecular search. One of the things that is really important for that is the ability to vectorize molecules, store those molecules in a vector database, and find molecules that potentially treat certain symptoms or certain diseases so that we can move forward with, let's say, a test, right? If I'm a pharmaceutical company. And in order to be able to find the most relevant results, and not just, let's say, the top K could be very, very irrelevant. In order to be able to find the most relevant results, we've implemented something called range search. And range search, instead of finding, let's say, the top 1,000 molecules in your vector database, it'll return only the most relevant molecules by saying, I'm going to specify a range within the target or the query vector, and I'm going to return all the molecules, all the vectors that lie within that range. It could be anywhere between 10 and 10,000, depending on the knowledge base that you have, depending on the vectorization strategy that you have. Moving forward, we've already seen actually quite a few users that use this type of functionality called range search inside of Zilla's cloud. And moving forward, I think we're going to see other workloads and other query patterns as well. So when you talk about a vector database, again, it's great for text, but it's not just for text as well. You also want it to be useful for a wide variety of other modalities and a wide variety of other applications. And that's why we really adopted this performance-first, vector-first strategy. Yeah, I think that's it for today, and I really hope you enjoyed today's video. If you did, please like, share, comment, and subscribe. And for folks who are interested in learning a little bit more, I also wrote a blog post about this. It's not as long as me rambling here, but I'll link in the description below. And in any case, I hope you guys enjoyed this video, and I'll see you for next time.